How do we install a filtration system? We have two options. Mainly, the first one is full stream. The full flow filtration uses a filter installed after the cooling tower on the discharge side of the pump. So the filter continuously filters all the recirculating water in the system, and the filter must be sized to handle the complete flow rate. So as it has to filter the complete flow rate of the circuit, you will need a larger filter, so your capital expenses will be higher. And also, there is the risk of any type of failure, or when maintenance is required, you would have to interrupt the filtration circuit and probably stop your production process. That is why we normally recommend the second option, which is the side stream filtration. Side stream filtration continuously filters a percentage of the flow instead of the entire flow. It can be a cost-effective alternative to full flow filtration that can easily improve the water quality, to reduce water consumption, and ensure efficiency of the cooling towers. These systems both remove suspended solids, organics, and silt particles for a portion of the water system on a continuous basis, reducing the likelihood of fouling and biogrowth, which helps to control other issues in the system such as scaling and corrosion. This improves the system efficiency and often reduces the amount of water blowdown. So you will also have the lower environmental impact. Side stream filtration systems are generally sized to filter from 10 to 10% or even up to 20% of the overall system flow. Filters are selected based on the percentage flow of the side stream filtration as the system is designed to handle. Right? For example, in a cooling tower with a recirculation rate of 1,500 cubic meter per hour, a filtration system sized to handle 10% would the recirculation rate would be sized to handle only 150 cubic meter per hour. So, in conclusion, these would be the main benefits of a filtration system. First, you have a reduction in water consumption, where you have a lower demand for makeup water, increasing the system's concentration cycle. Essentially, higher concentration cycles mean that water is being recirculated through the system longer before a blowdown is required. The less blowdown reduces the amount of makeup water in the system and also lower environmental impact. Second, you have reduction in energy consumption, as side stream filtration reduces the likelihood of scale and fouling in the heat exchanger surfaces. Even the smallest layer of scale or fouling on the heat exchange surfaces can reduce the heat exchange rate, forcing the system to work harder to achieve the desired cooling and in turn increases energy costs. Also, you have a reduction in chemical use. Chemicals are used to bind suspended solids in the water stream and prevent scaling and corrosion. Dirty water requires more chemicals than clean water because the buildup of solid contaminants provides a buffer that reduces the effect of the chemical treatment. A side stream filtration can remove suspended particles and reduce the need on any additional chemicals treatment, such as dispersants or biocides. Also, very important, you have a lower maintenance cost. Traditionally, cooling towers are cleaned by draining the tower and having the sediment removed either mechanically or manually from the sump. The costs associated with this cleaning process include downtime, labor, loss of water, and additional chemicals. So chemical systems that are clean with a side stream filtration routinely provide longer period of continuous operation before being taken offline for required maintenance. And finally, you have an improvement in your productivity process and a reduction in downtime. When a cooling system is fouled or has scale buildup, production may be slowed due to inefficient heat exchange equipment. In some cases, the cooling system and heat exchange equipment may need to be taken offline for repairs, decreasing your production. The control of biological growth and reduction can mitigate potential health problems also, such as those caused by Legionella. The use of a side stream filtration can minimize habitat surfaces and nutrients by maintaining lower particles levels in the water stream.